everyone. Everyone had a good morning so far? All right, so I need to hold you for a little bit longer, so before the lunchtime. I hope you don't mind, and I hope you can have a good half an hour with me. So today I'm going to talk about how to build a consistent and a secure container environment for our application, specifically from local to production. To begin with, this is me, Jack. At the beginning of my career, I did Ruby, and later on, after a few years, I moved to Node.js when it came out. I also spent like 1 or 2 years, short period of time, relatively, in Java, and most recently, I'm doing more and more Python. So that's why I'm here. Some of you may also know me from Codaholics. Any of you have been to Codaholics? Right? Thank you for coming. It's Codaholics. It has more than 3,000 members as a local tech community. If you don't know it, please feel free to join. We do monthly meetups. We share any technical topics. If you like to talk, if you like to just learn something or make friends, please come. Yeah, and that's free charge. It's a community for community itself. Now, my job is a full stack developer in LGT. Probably you have seen LGT outside. Yeah, LGT is a sponsor for today's PyCon and also for this slot. So LGT is the largest loyal family-based private banking and asset management group in the group. Many of you have not heard of it, but it has been in the world for more than 100 years with 6,000 employees. It covers many different cities, over 30 locations in the world. When I put the LGT sponsor logo together with others, it's quite like a stranger here. Even I put it together with these, it's quite different. When I put the LGT even together with the other financial services that I used to work for, it also looks like outlier because it is the only company is here today, and it's the only company sponsoring PyCon, and would like to connect with you guys. So today my topic is going to talk about how our journey in LGT to build something secure and stable, reliable, which is definitely the requirements in financial institutions in such a critical area, but also do it in a fun way that we don't want every developer to stuck like your tech stack for 20 years. Right? Before we dive into any technical topics, my personal time, I'd like to plant something at my home. Right? So if I remember, this is sunflower. We bought some sunflower seeds from markets. We put them in identical cells and put the soils. We gradually see them grow, and when size grows, we have to move them to a bigger container. And and we have to put them separately in identical cups. We provide them very identical environments, same soils and water. We look after them exactly in the same way. However, the outcome is we don't see the result is always the same. Sometimes some of the plants is a little bit closer to the window, they get a little bit more sun exposure. Sometimes we put water on it. We do not cover every plant evenly. This introduced to the topic that during the software engineering process, even if there's a little bit environment difference, it could eventually end up with very different results. So this is the environment consistency topic exactly. So a typical example here in your local, you may use your Windows, Mac, Linux, your own choices. When you start a project, you just, I need PostgreSQL, I just download whatever is the latest in the markets. I will also want a MongoDB, and I just use MongoDB single nodes because that's enough for your local development. I don't need to use Docker because I just don't need it. However, in the production, you probably use Linux, maybe in a Kubernetes cluster. You use PostgreSQL, but the PostgreSQL, I don't believe you change it quite often. You probably stay with whatever is very stable in the past. And for the, MongoDB as well, when you scale up, you like to use a replica set to support much more usage. And when you build something to Kubernetes, of course, you need to use Docker at the build process, right? You see Linux on both sides, but most likely in your local Linux and your deployed environment Linux are not exactly the same in OS or in the version. So anything we come across in the production environments on the right-hand side can not be very easily detected or debugged in your local environments. The consequences, you see flaky tests, something is working in your computer but not in your team members because they join team a bit later and they use a younger version of whatever package. And your test is working perfectly in your local, but in production it's a different story. And you have deployment surprises because you only use Docker in your CI/CD and you don't build your image in your local, right? You have debugging nightmares because you have to debug something in the production environment. However, you don't really have the same thing in your local, and it's very difficult to reproduce the same issue. And you get silent failures like memory leak. Memory leak, you find it in the production because there may be an OS dependency that is a cause of memory leak, but your OS is completely different. And security vulnerabilities, of course, but I will cover this topic a bit more. So this end up with a comment saying it works in my machine, but you don't care about the fire burning elsewhere. Some of you may think it's a little thing that happens maybe only once a year. The other thing, okay, I can spend a couple of days to look into that, but it's like the triple effect. When you have very little, this small thing here and there, it can gradually propagate to much larger area and have a big impact in terms of your productivity and your maintainability. Another issue with the traditional environments for development is the security. Imagine now you are building such application, let's call it Little Plant. Right? Little Plant, it is something you developed in your own computer. In the traditional way, it could access to your host. It could attack your host. It could have access to your mails. It could even steal your credentials, passwords, and it could access to your codes. I remember there was, maybe end of last year, there was React or another popular open source library that was hacked because somebody has malicious code in the local environments, and that allowed them to do a pull request to an open source library with a very subtle change in the README. However, the branch name is the trigger. The branch name actually can run some command line once the branch is in the GitHub. So that eventually propagated to a much larger area. It started to do some coin mining in many different places. It's really like the end of the world. Of course, you can pay a lot of money to install other software to manage your application. You can have your IT department to provide you with very limited access as a developer in the machines. Of course, all of this comes with the cost. Wouldn't that be a simpler way if you just encapsulated your application into the box so that it would not have access to any resources it should not have the right to, and just put everything you need within the box. So this drives to my first topic is the Dev Container. How many of you have used Dev Container ever before? A bit rare, maybe 5, 3. All right, so Dev Container is basically like a container environment. It's not for your production, but for your development. This is a very simple example. Maybe the text is not very ideal. So basically it sets an image as a Python to begin with. You can have your customization as IDE, and you can have a port forwarding, and you can set a lot of things. So that when you have this together with your teammates, you can basically use the same configuration. Everybody get the same thing. In general, if you are building this Little Plant application, you may need several different backends, right? So you may need a backend to do authentication, you may need a backend to provide you data or something, and you may want several databases to begin with. Imagine if you want to put up such application in your local environment, I need to start 4 or 5 applications in order to have a proper running interface. But with Dev Container, we can build all this with a Docker Compose. You may want to have a consistency across your team, to have terminal processes, have ID setting, extensions. You want to do some AI coding assistance to align with your team members, and you want to debugging as well. So all of this could be encapsulated within Dev Containers so that you can maintain that within the team. A lot of the advantage with this, so it gives you the consistency and the reproducibility. You can align your Dev Container image to share the common part with your production image. It greatly isolates your environments within the host so that you don't worry about the application will hit anything in your machine. And it's much cleaner so that you won't end up with like gigabytes of the cache files and the log files, because anytime you just delete the container, you can start from scratch. Dependent management, you can easily see what are the application dependency in the charts. Developer experience, especially for new joiners, when they join the team, they don't have to pull different resources. They simply just need to run the same dev container. Team collaboration as well, you get the same thing with your team members. Context switch, once you need to do a pull request, however you are still in the middle of your task, Dev Container allow you to start a completely new Dev Container just to review the code, and you can switch to your previous container, which to do your own development work in a separate branch. CI/CD I will cover in a bit. Right? There are also a lot of the issues that we need to overcome. So in general, there is a bit of learning curve. If you have a sophisticated application to develop, you basically need to tailor-make your perfect Dev Container configuration with your team. It may take some time, but if your project is targeting for long term, I think it's worth the effort. I won't mention too much about this part. All right, so once we calculate Dev Container, we end up with something like this. There's a box. At the bottom, you may have the OS, consistent, fixed, and then you have your system dependency. Then your application is running at the top. Right? Your application may have other libraries, Python packages, third-party, whatever dependencies out there. And your system dependencies may also have their dependencies, which is outside of the Dev Container. Right? You can expect nowadays every software has vulnerability. You can see something could be directly used by the application, has an issue, has a vulnerability. It could be a transient package which has vulnerability as well. Meanwhile, the OS actually itself can have vulnerability, and actually any boxes here could have a chance of being full of vulnerabilities. When we look at a different chart here, if we imagine that this is kind of the ideal world in my mind, that within the Dev Container, you don't have the different layers. Instead of imperative, we prefer to have declarative, so that you basically define what you need. There's no interdependency between your packages. You just define each of them as a single unit as you want. The reason why is once we build our Dev Container and we start to think about, okay, what's the image to use? We learn lesson from tackling vulnerabilities. So for example, this is a Python image I just put at the Dev Container configuration. You can see just 7 days ago, now it has already got one high-level vulnerability. You may think about, oh, I want to get something simpler, like Alpine. Alpine is much thinner. It's a minimum package, but when they look at that, it's not a very new version. I think it's been about several months, but when you look at that, there are so many vulnerabilities from critical and high critical level. When we look at that, actually most of the vulnerabilities is related to the OS itself, Debian, OpenSSL. There are things you cannot easily mitigate by yourself. So when you use such an image in your Dev Container, the nightmare is you have to upgrade it very often, and you basically don't want your teams to put your time here. Especially nowadays, the number of the CVEs grows rapidly. I got the data, I think, by the end of last week, but I imagine 2025 will definitely go even higher than 2024. So this comes to our next solution, which is to use Wolfi-based image. Any of you have been using Wolfi-based image ever? So it's relatively newer. You need to put more efforts, but Wolfi basically, the image provides you the OS that is mainly for container, not for your for your daily operations to process document, or not either for similar thing as Ubuntu, things like that. It's very targeting for container environment. Second part, by design, it has guarantee with no vulnerabilities, so that you can always begin with a clean sheet at the base. And it's also based on glibc, so instead of Mussel. So Mussel relatively is more common used in Alpine images. However, it's not that compatible if you build like enterprise level application. And it also, the Wolfi basically is a product behind the company called Chen. Chen provides also tools like APKO and Melange, which allow you to build APK packages. And it has SBOM support. Basically, when you build some package, it allows you to see what's the composition of the package. So you can easily identify what is the cause if something is vulnerable. So yeah, at the end, Wolfi gives you developer the secure by default base they need to build software. So that's everything. We saw we can directly use Python image nodes from official provider. However, we decided to go with this because we wanted to have the base as something we can be sure that it's something clean, it's something that is like reached to the high standard in the industry with no vulnerability, which is something like as a signed image. And we built the Python, no matter Node for front end or Golang for pipeline, all based on this Wolfi-based image. And then we build our application on top. So that once we know that something goes wrong, for example, if Python's particular version has vulnerability, then we just upgrade Python itself or any package of the Python, so that we don't have to worry about the OS level or some system dependencies that you don't have any control of. Right? If we look at the pipelines, let's say if we are still building this application in the local, we run it the local, and then we push it to the pipeline, we run the test. During the test, if test gives a green light, then we continue proceed to the build process into a build application, and at the end, your application will be running in a container itself. And the container will be scanned in the following process, and at the end, it will be deployed to production. The beauty here is, apart from production, you got all those environments with the same Dev container image. So even from local, test, build, and scan, all of them use the same environments, particularly with the same hash of the Dev container. So that anything you find, oh, my build process is broken, or some test is wrong, or the scanning provides something as a hiccup, you can easily reproduce that in your local environment. Of course, production environments, you don't need the whole Dev container because your Dev container provides a lot of dev tools that your production doesn't need. But the Python image at the end is something we build ourselves, and it's also based on the Wolfi-based image. All right. Now, if we further grow up, we don't have only one microservices in your local environment. You gradually grow up from one little thing to like many microservices in your local environment. You have more dependencies, may grow up to this level. Right? A common topic is that, oh, how can I handle these common dependencies? For example, let's say package A is used by several of your applications. How can I deal with this if A is installed with different versions in different application? I have version 12, A in the first, and version 13 with another applications. If something goes wrong, should I upgrade one A or should I upgrade every A? Right. The solution that we gave is to use a polylith architecture. The architecture was not created only for Python, but somebody brought it to Python. In general, if you have multiple applications in your local environments, it introduces you a model repo architecture. So all of your projects are split into 4 categories. So base, components, development, and projects. So base, you can take that as your API layer, which is something can be exposed to external world. And the components are something not meant for exposing to outside, which are like your authenticator, which is something like your data ORM, something like that. So development is mainly for your local exploration, which will not be deployed. And the last part is the projects. When you look at the bottom, the few blocks, you see one project can pick different bases or components, and the libraries are something you want to install, like I say, Python packages, and then encapsulate that into one single project, which is like a unit to deploy. So basically, it's like a Lego block, right? You pick what you want and to make your own tool. The beauty here is for every component, you are only supposed to have one copy of that. So your component, if that's working in your first application, it definitely should perform exactly the same in the other applications. And once you need to upgrade one, you have to imply that same change in all the project that you deployed. So the benefit is that you have only a single source of truth. You don't have different versions for the same package in different areas. Like you have atomic updates. So if you update your authenticator, the updates is applied in all of your projects. You get a consistent code structure and build process because everything is structured in a similar way. You can have your Dockerfile templates and to be reused. And because once we think of this Lego blocks, you basically want to remove everything you don't need. So it also reduces the attack surface. At the end, simplified dependency management, that's something I can show you in a demo later on. I think I still have 5 minutes. Let me show you a quick demo. Right, I think I need to mirror.
Do you display settings?
Yeah.
Display setting. This one? Yeah. And then display change to mirror for AAA.
Right.
Yeah. Okay.
Right.
Then just switch to your VS Code.
You know how I can hold the mic. Just leave it here. Okay. I will try to speak a bit louder. So this is my IDE, and this is my Dev Container configuration that is a little bit more complicated than the example I showed you before. You have your Docker Compose, which includes several services. So at the bottom of the left, you can see you have your app, and you have your Kafka, you have your Zookeeper. So many of the services are within the same Dev Container, so you don't need to worry about boosting them in sequence. And you have your customization, you have your VS Code settings, all the things. And you can have a pull forwarding, whatever, everything is here. So I pre-built it. I think it only takes about like 2 minutes. But let me try to start everything. So once it is started, so you can see all of the services all up all together. And here I can have this Dev Container. I can click into that. Now so PyCharm is going to launch with a new IDE client in a few seconds. Right. So it launches a new environment. So this environment is separate from what you have just seen. So here, if you look at, sorry, I don't know how to make it the fonts a little bit larger. Okay, so basically this is the environments within your Dev Container, which doesn't have access to the outside. But here, I have the same source code because the Dev Container mounts the source code from outside, but it doesn't have any other accesses if you don't allow it to. You can see that, for example, the UV, the polylith thing I just showed you. For example, you can say polydepths. Let me pull it up so you can have a clear view. So basically, the green parts I think are the components. The blue parts are you can take the base, which are your main applications. So you can see which components is used by which application out there, or which API. You could even see the library dependencies, right? So So this is just a very simple example, but you can see that the white ones are basically the libraries that you use across all those different blocks. You can easily identify what's the impact if you upgrade one library, right? And you may also want to do some changes. Let me have quick one. So let's say I go to components. I want to change, let's say, message component, right? So it's almost empty, but let me put down something. For example, here, can I just say print hello PyCon, right? And then I made a change. This is a change in a component. I expect it's shared in several your APIs. When I do UV run poly diff, so it shows you that I just have one single change, but the change is going to impact all of these projects, right? So the change is only done in the message fast API. However, the change will be also included in all of those components. So that if you have a CI/CD pipeline, if you change something, you will directly know what are the package you need to deploy in order to make this change applied to everywhere. You could also have your test change. So let's say if I modified one of the tests, let's say maybe the log, right? I put here, make another quick change, right? And then I run poly test diff. So this is going to show you, right? So what are the projects impacted by this test change? Because this test is something belonging to the component, and the component is used in all of these projects. All right, let me switch back. Okay, maybe just do this. All right, and this goes to the end of the demo. By the way, if you haven't been to our counter, we're LGT outside there. We're actively hiring full stack developers. If you have not settled in your working environment, if you look for somewhere you can work without much limits, please feel free to reach to us. Thank you very much.